In the 1600s, Sir Isaac Newton came up with three basic laws that apply to almost everything we see in everyday life. They explain why things remain stationary or move around, and are fundamental to all engineering disciplines, as they control how liquids flow, how cars work, how bridges don't fall down, and basically how everything around us moves. Newton's first law states that a force is necessary to change the state of rest or uniform motion of an object. The motion or lack of motion of an object will not change without an unbalanced force acting on it. This allows engineers to predict the movement and behavior of stationary or moving objects. For example, we know that in space an object will move at a constant speed in a straight line until a net force acts on it. Therefore, we can predict the movement of an object such as a spacecraft by calculating the net force acting on it. The second law states that the rate of change of momentum of an object is directly proportional to the net force acting on it. The momentum of an object is equal to the mass multiplied by the velocity. If we call the velocity before the force is applied u, and the velocity after v, the change in momentum can be written as mv minus mu. Factorizing, this becomes mv minus u. Therefore, rate in change of momentum is mv minus u over time. We know that acceleration is the change in velocity over time, so we can say that the force is equal to the mass times acceleration. This tells us that the acceleration is proportional to the force as long as mass remains constant. An object with a large mass and a small force applied to it will accelerate very slowly. The third law states that when body A exerts a force on body B exerts an equal and opposite force on body A. Forces are always found in pairs. Imagine yourself jumping on a bouncy castle. Your body exerts a force downward, so the castle exerts an equal upward force, otherwise you would fall straight through it.